So we should begin continuing our the about infinite products. Let me recall first the definition, what we mean by the convergence of an infinite product. And given an infinite product, we say that this infinite product of numbers Pj, which we have denoted again, we are using this notation. We say that this is convergent if the following condition holds, that is, the limit of Pj goes to 1, or you can say if Aj goes to 0 as j goes to infinity. And the second thing is that this series log Pj has to be convergent. If you have these two conditions, then we say that this infinite product is convergent, and this infinite product is said to be absolutely convergent if the series log summation log p is absolutely convergent. If this series is, if it is absolutely continuous, then it is said that the product Pj is absolutely continuous infinite product. Sorry, not absolutely, it is absolutely convergent. It's absolutely convergent. So, what was the relation between convergence and absolute convergence? We had seen that it is quite clear that if a product is absolutely convergent, then it is convergent also. That absolute convergence implies the convergence. And now, what about its converse? And the converse is not true. Let us look at the following example, which will make it clear that a convergent product may not be absolutely convergent. Consider the infinite product 1 plus minus 1 to power k plus 1 upon k. This was the first product yesterday that we talked about, and we had seen that this is a convergent infinite product. Consider this, and we know that it is convergent. We know it is convergent. But let me recall another result from yesterday. That result stated that if we have the product 1 plus aj, j running from 1 to infinity, then this product is absolutely convergent if and only if the infinite series made up of aj's is absolutely convergent. So using this result, let us check whether this infinite product is absolutely convergent or not. So here aj's are, here aj is, let me ak denoted, index हम k से denote कर रहे हैं. Ak is equal to minus 1 to power k plus 1 upon k, and the series made up of, because we have to check the absolute convergence of the series made up of these AKs, and the series made up of these AKs has to be minus 1 to power k upon k is not absolutely convergent. Why it is? Because is not absolutely convergent, because for absolute convergence, we need taking mod of the each term of this series and then form the series. If that series is convergent, then we say that the series is absolutely convergent. But if you see the mod, taking mod of the each term of the series, you get the series which is harmonic series, because mod of minus 1 to power k plus 1 is going to be 1. So this series is a harmonic series, and we know that it is not convergent. It's harmonic series. And what do we know about harmonic series? That it is not a convergent series. So this series is not convergent. Therefore, this product is not absolutely convergent. Thus, what it says, it follows that the product which is convergent, although but not absolutely. This infinite product, you can take a from 1 to infinity, is not absolutely. So you have, okay, absolutely. It's not absolutely convergent. So you have this counter example which tells you that the absolute convergence imply, even the absolute convergence implies convergence, but convergence doesn't imply the absolute convergence. So we have another observation also, and the other observation is the following remark, that for which I will give you an example. And this says that uh, absolute
Yeah.
एब्सोल्यूट के स्पेलिंग मुझसे हमेशा मिस स्पेल हो जाते हैं.
अच्छा फोन ले जा अपना अंदर, ये लड़की का कोई पता नहीं.
ये माइक बंद कर दो जी अपना, घर के काम करने वाले. Absolute convergence of an infinite series, sorry, we are dealing with infinite products. Infinite product is not equivalent to the convergence of the product, so the product of the absolute values of the absolute values of the factors. So this is the thing that says that, suppose we have two situations, how you can understand it. If we have a product AJ, and when you say that this is absolutely convergent, so absolutely convergent means this series mod log of 1 plus AJ is convergent. This is the definition of absolute convergence. And the other thing is that if we form the series, if we form the infinite product by taking the mod of each term, this is what we do in the series, in the case of series. क्योंकि series के केस में क्या होता है, series के केस में आपकी series absolutely convergent है अगर आपके पास सीरीज की टर्म्स का एब्सोल्यूट वैल्यूज लेकर आपकी सीरीज कन्वर्जेंट हो जाती है. तो बट प्रोडक्ट में ऐसा नहीं है. प्रोडक्ट की एब्सोल्यूट कन्वर्जेंस इससे नहीं फॉलो हो जाती कि आपके पास मॉड लेकर अगर आपकी प्रोडक्ट कन्वर्जेंट है, दैट डजंट मीन कि आपका प्रोडक्ट एब्सोल्युटली कन्वर्जेंट है. सो वी हैव टू सी कि अगर आपका प्रोडक्ट फॉर्म करते हो बाय टेकिंग द मॉड ऑफ द फैक्टर्स, if that product is convergent, that doesn't necessarily imply that your product is absolutely convergent. So we have to consider an example, and let us look at the example. 1 plus ik. Okay, so you can see it in any ways that whether this series is this is convergent, it is absolutely convergent or not. One of the things that you might use, that again the result that I stated here, this one, this result, that this product is absolutely convergent if the series is AJ is absolutely convergent, but This is not absolutely convergent. So the simplest way, even though it is not convergent also, but just because I need to establish a connection between the absolute convergence of the product and the convergence of the product of the absolute values of the factors. So then see, this is not absolutely convergent. This is not absolutely convergent. Why? Because अगर ये absolutely convergent होता तो आपके पास series summation made up of ik, this would have been absolutely convergent. But ये absolutely convergent होने का मतलब इसके mod को लेके जो series form करते हो तो उसको mod को लेके series form करोगे तो mod of I आपके पास 1 होता है तो this is 1 upon k. And you know that because this series, you know that this series comes out to be harmonic series and this series is not convergent. It's not convergent, and the absolute convergence of this product is happens if and only if this series is convergent. So this series is not convergent, therefore this product is not absolutely convergent. But mm, but the product formed by taking the mod of the product factors of this product, and this is the product 1 plus I upon k, इसकी वैल्यू उसका mod ले लीजिएगा, is convergent. And why it is convergent, let's see. uh, why it is convergent. Now look at this thing. So इस इनफिनाइट प्रोडक्ट की कन्वर्जेंस के लिए हमें क्या चाहिए, डेफिनेशन क्या है इनफिनाइट प्रोडक्ट की कन्वर्जेंस की, कि इसके करस्पॉन्डिंग जो सीरीज बनेगी log of mod 1 plus ik, ये सीरीज अगर कन्वर्जेंट है then by definition of convergence of infinite product it will follow that this product is convergent. So let's check out that whether this series is convergent now. But for that we have to use an inequality and estimate from the log function. And what is that estimate? The estimate is that clearly each number is greater than 1, so uh, log of mod of 1 plus I upon k has to be strictly greater than 0. And if you calculate this 1 plus ik का mod अगर आप calculate करोगे तो it has to be 1 plus 1 upon k square whole raised power 1 by 2 होना था, but 1 by 2 को आप क्या कर सकते हैं, क्योंकि log में है तो you 1 by 2 को आप उससे multiply कर सकते हैं, ठीक है. So you have this estimate. And this number, if you see the expansion of this log, then this number is less than 1 upon k square. This number is less than or equal to k square. So what it implies? It implies that 1 by 2 log of mod of 1 plus I upon k is less than or equal to 1 upon k square. So hence, and since we know this, since we know this series 1 upon k square is convergent by p test, what you known as, because यहाँ पर power 2 है convergent. So by comparison test, क्योंकि now the dominating term जो है आपके पास convergent series की है, तो so by comparison test it follows that this series log mod 1 plus I upon k is convergent, and this in turn implies that the product formed by the 1 plus ik, taking the absolute values mod of these numbers, is convergent. So we have this thing that if we take a product which is not absolutely convergent, but and if we at the same time form a product by taking the absolute values or the mod of the factors of the product, then that might be convergent. So that means the absolute convergence, the way we define this in the case of series, is not is it not going to be the way, is not going to be the same way in case of infinite products. So you have any questions, any doubt up to this? Let's move on then. So now let's okay, we don't have to deal with only the numbers, we have to go to the functions. And the first thing that we are going to import from the convergence, uniform convergence of series of functions is the Weierstrass-M test and its version for the infinite products. And this is the topic that I have to cover here in the form of a theorem. And what is, you first observe what it is this. Suppose we have a function gkz defined as 1 plus hkz, where k is any number greater than or equal to 1. And suppose these are functions and defined on some set E. This set can be any set, जरूरी नहीं कि complex numbers का set हो. This can be arbitrary set. And but the only thing is that these are complex valued functions. And further, we suppose there is, yeah, there are constants. There are constants m, k, each constant positive, such that the series formed out of these constants is convergent, and each hk is bounded by the corresponding constant m sub k for each z in E. This is the hypothesis. That means each hk is bounded by this constant m k. Then the infinite product of these functions converges, not infinite product, sorry, I have to take the partial products first. I have to take this m, this is m, then this partial product of these functions converges, because this is a function again, so you're getting a sequence of functions. Then this is a function, this is a finite product of functions, so it's a function. It converges to this product gkz, and this is k equals to 1 to infinity, but it converges uniformly on E. It converges uniformly on E as m tends to infinity. So this is the context, that this is the Weierstrass-M test for product of functions. So the thing here is that implicitly, without going into the details, I'm considering that this product is defined. Let me tell why we are doing so. Let's first deal with this. So what is the hypothesis? We have this thing, but what you can say, the first we talk about pointwise convergence of this product. Pointwise convergence of not summation, but pointwise product of this 1 plus hkz. So for fixed point z, let us fix some point z in E. Then this product is a product of numbers now. And we know that this product is absolutely convergent, absolutely convergent if and only if summation hkz is absolutely convergent. This is the necessary and sufficient for condition for the convergence of absolute convergence of an infinite product of numbers. So now, but by hypothesis, each mod of each hkz is less than or equal to mk, and the series formed by mk's is convergent. So hence, by comparison test, comparison test, it follows that the series of the numbers mod hkz is convergent. When the series is convergent, that we say that the series hkz is absolutely convergent. And so if this series is convergent, what follows from the necessary and sufficient condition of convergence of absolute convergence of the product, that this product 1 plus hkz is absolutely convergent, and absolute convergence is always convergent. So this is convergent for each z, and hence it defines a function. Hence it defines a function. Hence, for each z in E, this number gkz, which is 1 plus hkz, k from 1 to infinity, is a finite complex number. Is a finite complex number. Give me a minute. Okay, so this is a finite. Am I audible now?
Yes, sir.
Yes, sir.
So this is a finite complex number, and hence uh, for each z, this is a defined function now. K from 1 to infinity, gkz defines a function. Defines a function. Okay, so it's done. That's why we are using it. Now we have to establish its uniform convergence, and the uniform convergence of partial products. But before that, I have to use some estimate for which you can verify or get from somewhere about the log function. So let us take, I have to choose, this is an estimate for log of 1 plus w. I can choose a constant, finite constant, so that I can write this modulus of this log of 1 plus w less than c times mod of w for w in a half disk. This is something that we can choose. And so that better to say, let c be a constant such that we have this estimate. Okay, we have to use this thing. Now, further, since the series formed by mk's is convergent, and the necessary condition for this convergence of series that its kth term goes to 0, so that means convergence of series formed by the constants mk's implies that this mk goes to 0 as k tends to infinity. So using the definition of the limit, I can choose a number n such that mk is a positive, so I'm not going to mod mk is less than or equal to 1 by 1 by 2 for all k greater than or equal to m. You are taking epsilon equal to 1 by 2. That's it. So from here it follows that mod of hkz, which is less than or equal to mk, is less than or equal to 1 by 2 for all z in E and k greater than or equal to n. Thus, now let us look at this mod of log of 1 plus hkz. We have seen that log का estimate है आपके पास, this is less than or equal to C times M of K. So now let's look at the series log mod of 1 plus, this is a series of functions, and we have to see this thing. But you see the each function in this series is dominated, or y to take mod. We don't need to take the mod because I have to use a Weierstrass M test. So each term in this series is dominated by this number C times mk, and we know that this series mk is convergent, and hence by Weierstrass M test, Weierstrass M test, it follows that this series summation log of 1 plus hkz is uniformly convergent. Is uniformly convergent. This is the something that we get from Weierstrass M test, if you remember it properly. So we got to see that this series is uniformly convergent on E. So what it implies? If this series is uniformly convergent on E, that means, and this means that this product let's not talk about product, by the way. That means okay, what we are going to do now, this is a series which is uniformly convergent, and what we are going to do, we are going to take the exponential of this series. एक्सपोनेंशियल फंक्शन से आप इसको कंपोज करो, तो जब एक्सपोनेंशियल फंक्शन से आप इसको कंपोज करोगे, द एक्सपोनेंशियल फंक्शन इज अ वेल बिहेव्ड फंक्शन, तो इट विल नॉट डिस्टर्ब द यूनिफॉर्म कन्वर्जेंस. So this means that let me interpret in another way also. It also says that that is to say, that is the sequence summation k from 1 to m log 1 plus hkz. This is a sequence where m ranging from 1 to infinity. This is a sequence of partial sums, na? So this is a sequence of functions is uniformly convergent. क्योंकि कोई सीरीज कन्वर्जेंट होती है जब उसके पार्शियल सम्स की सीक्वेंस कन्वर्जेंट होती है, दैट मींस दिस सीक्वेंस इज यूनिफॉर्मली कन्वर्जेंट ऑन ई. तो अगर आप इसको एक्सपोनेंशियल फंक्शन से इसको कंपोज करो, तो हेंस लेट अस एक्सपोनेंशिएट it, we get what we will get this sequence exponential of summation k equals to 1 to m log of 1 plus hkz. You are getting a new sequence. आप एक्सपोनेंशियल से उसको कंपोज कर रहे हो, तो उसे यूनिफॉर्म कन्वर्जेंस चेंज नहीं होती जी, बी केयरफुल, क्योंकि आप कंटिन्यूस फंक्शन एंड इट इज अ मच बेटर कंटिन्यूस फंक्शन. So this is uniformly convergent. This is uniformly convergent to, and to what it converges, and it is uniformly convergent. But let's look at, but what is this number? Exponential of summation k from 1 to m. This is log of 1 plus hkz. What is this number? Again, this is a finite number, and we are going to use the exponential and log property and the property of exponential in sum being get converted into the product. तो ये product में convert हो जाएगा. It will be k from 1 to m. It is exponential of log of 1 plus hkz, and this thing is exponential log आपस में inverse है, तो you are getting only hkz. So this is the partial product, and hence it follows that the sequence of partial products is uniformly convergent, and to what it must converge. ये उसी को converge करना चाहिए जिसको ये point wise converge कर रहा है. This is g in that, मैं g use करता हूँ. Okay, so we get thus we see thus it follows that it follows that the sequence mm, of partial products k from 1 to m gkz, changing m from 1 to infinity, of partial products is uniformly convergent. और ये उसी नंबर को उसी फंक्शन को कन्वर्ज करेंगे जिसको पॉइंट वाइज लिमिट पॉइंट वाइज ये कन्वर्ज करते हैं एंड since the point wise limit of this sequence of partial products m equals to 1 to infinity, we know that its pointwise limit is this infinite product, तो यही यूनिफॉर्म लिमिट भी होनी चाहिए थी. So it follows that these products converge uniformly. These products converge uniformly on E to this infinite product, this function that is formed by this infinite product. Do you have any other questions? So this is the beautiful proof to establish the uniform convergence. Is it okay? Yes, sir. You just take the proof out of this thing जो notes पे आएगा, that is not इतना explanation नहीं है, इस पे ज़्यादा explanation दी है, तो you can copy this proof from here, but proper way से. So let me go to now कि एक एग्जांपल मैं आपको दे रहा हूं जिसमें इनफिनाइट प्रोडक्ट कन्वर्जेंट इनफिनाइट प्रोडक्ट की वैल्यूज को आप इवेलुएट कर सकते हैं एंड आई हैव टू इवेलुएट द वैल्यू ऑफ एन इनफिनाइट प्रोडक्ट. Evaluate the value of this infinite product 1 plus 1 upon n into n plus 2. So this is n from 1 to infinity. So first evaluate आप तब करोगे, पहले आपको establish करना है कि whether it is a convergent or not. तो अगर आप इसको इस फॉर्म में लिखें, let us take an to be 1 upon n plus n into n plus 2, then c each an is a positive number and the series आपको चेक करनी है 1 upon n into n plus 2 is convergent. Why it is convergent? Let me take a little detour and to tell you why it is convergent. I hope you, let me change the color. You see, I'm going to use the comparison test to establish that this series is uniformly, this series is convergent. There is no way to talk about uniform convergence of the series of numbers. And look at this, n into n plus 2, this is equal to n square plus 2n. Yeah, it is okay. So this is greater than n square. This further implies that 1 upon n into n plus 2 is strictly less than 1 upon n square, and so each term of this series summation 1 upon n into n plus 2 is dominated by the terms of the series 1 upon n square. So by comparison test, it follows that this series 1 upon n into n plus 2 is convergent because the series 1 upon n square is convergent. Yeah, so the series is convergent and hence the product is convergent. Therefore, the product 1 plus 1 upon n into n plus 2 is convergent. ओके, सो अब कन्वर्जेंट है तो लेट्स सी कि इसका वैल्यू क्या है. तो वी नो दैट व्हाट इज द वैल्यू ऑफ 10. इसकी वैल्यू कितनी होती है इनफिनाइट प्रोडक्ट की, n इक्वल्स टू 1 टू इन्फिनिटी 1 plus 1 upon n into n plus 2. We know that इसका वैल्यू जो होता है, इसका वैल्यू इज लिमिट m tends to infinity summation product n equals to 1 to m, and it is 1 plus 1 upon n into n plus 2. Yeah, this is the value. तो अब ये पार्शियल प्रोडक्ट्स हैं, तो लेट्स कैलकुलेट द पार्शियल प्रोडक्ट. ओके, नाउ वी हमें इसकी लिमिट, तो let me denote this partial product by pm. Let me denote this partial product by pm. Now let us look at this pm. What is this pm? Green is not a good color to write. pm is equal to पहले तो इस नंबर को आप थोड़ा सा सिंप्लीफाई कर लो. व्हाट इज दिस नंबर? 1 प्लस एन, 1 प्लस 1 अपॉन एन इंटू एन प्लस 2 को जब आप अगर सिंप्लीफाई करें तो इट विल बी एन इंटू एन प्लस 2 प्लस 1 अपॉन एन इंटू एन प्लस 2. तो ये न्यूमरेटर आपके पास एन स्क्वायर प्लस 2n प्लस 1 बनेगा, विच इज नथिंग बट, लेट मी राइट, एन स्क्वायर प्लस 2n प्लस 1, तो विच इज द n प्लस 1 का होल स्क्वायर है ये n प्लस 2. सो दिस पी एन में ये जो टर्म आपके पास आ रही है, दिस इज n equals to 1 to m. This is n plus 1 whole square upon n into n plus 2. Okay, so let us see this thing. N plus 1 whole square upon n into n plus 2. तो आप इसको वैल्यू सब्स्टिट्यूट कर लो, n इक्वल्स टू 1 से लेकर m तक, देखते हैं क्या आता है. n इक्वल टू 1 सब्स्टिट्यूट करोगे तो पहली टर्म आपके पास 2 स्क्वायर आएगी नोमिनेटर में, और डिनोमिनेटर में आपके पास आएगा 3. ठीक है, 1.3. दूसरी टर्म आपके पास आएगी जब n इक्वल्स टू 2 सब्स्टिट्यूट करोगे, इट विल बी 3 स्क्वायर, और डिनोमिनेटर में क्या आएगा, इट विल बी 2 into 4. फिर then you substitute n equals to 3, you will get 4 square, and denominator में आपके पास आएगा 3 into 5. Then you will have 5 square, and you are going to get the pattern. Then it has to be 4 into 6, so on so on. Last term आपके पास क्या होगी, it has to be m plus 1 whole square upon m into m plus 2. तो कुछ ऑब्जर्व करो जी इसमें. देखिए, एक 3 आपके पास, ये लेट्स फोकस एट दिस सेकंड टर्म, इस पे फोकस करो. इसकी 3 स्क्वायर है ना नोमिनेटर में, तो इस 3, ये 3 स्क्वायर सारा खत्म हो जाएगा. एक इसके लेफ्ट से खत्म हो जाएगा, एक इसके लेफ्ट में 3 स्क्वायर है, 3 है, और एक इसके राइट में 3 है, तो 3 स्क्वायर खत्म हो गया. ठीक है, फिर इसी तरह 4 स्क्वायर देखिएगा, 4 स्क्वायर भी खत्म हो जाएगा. 4 एक इसके लेफ्ट में 4 है, वहां से खत्म होगा, एक इसके राइट में 4 है, वहां से कैंसिल होगा. Same will happen with 5. So everything is cancelled out. Everything is getting cancelled out. और फर्स्ट वाली जो टर्म है, फर्स्ट वाली टर्म में क्या है, फर्स्ट वाली टर्म में 2 बचेगा, क्योंकि एक ही 2 कैंसिल होगा इसका, क्योंकि इसका राइट में है, लेफ्ट में इसके कुछ नहीं है. और लास्ट वाली टर्म में क्या होगा, लास्ट वाली टर्म का लेफ्ट साइड वाला कैंसिलेशन होगा. दैट मीन्स m प्लस 1 एक कैंसिल होगा, एक m बचेगा. ठीक है, तो बाकी बाकी एक वर्जन, और m तो ऑलरेडी कैंसिल होगा, क्योंकि इसको m पर लेफ्ट से कुछ आ जाएगा, ये कैंसिल हो जाएगा. इज इट ओके? ये समझ आ रही है आपको, ये कैंसिलेशन कैसे हो रही है?
यस सर।
ठीक है, अब आपकी फर्स्ट टर्म में क्या बचा, फर्स्ट टर्म में आपके पास सिर्फ 2 बचेगा. और लास्ट टर्म में आपके पास क्या बचेगा, लास्ट टर्म में आपके पास न्यूमरेटर आपके पास एक ही कैंसिल हो रहा है, m प्लस 1 बच रहा है. तो m प्लस 2 आपके पास इसके नेक्स्ट स्टेज में कैंसिल होना था, बट वो है नहीं है, तो आपके पास m प्लस 2 बच रहा है. यू आर हैविंग दिस थिंग. तो हेंस जो लिमिट आएगी इस पार्शियल प्रोडक्ट की, m टेंड्स टू इंफिनिटी, n इक्वल्स टू 1 टू m, n plus 1 whole square upon this is n into n plus 2. This will be equal to 2 constant है बाहर निकालो. This is limit m tends to infinity. This is m plus 1 upon m plus 2. तो ये m plus 1 upon m plus 2 की लिमिट 1 आती है, तो सो यू हैव लिमिट 2. तो हेंस आपके पास जो वैल्यू है इस इनफाइनाइट प्रोडक्ट की, देखिएगा n इंटू एन प्लस 2 की जो वैल्यू है, ये प्रोडक्ट है, इस प्रोडक्ट की वैल्यू आपके पास आती है 2. ठीक है, तो इस तरह से यू कैन कैलकुलेट अदर प्रोडक्ट्स आल्सो, उनकी वैल्यूज को फाइंड कर सकते हैं. यू माइट हैव टू वर्क लेटर. So this is all about for today's, and if you have any questions, any query, please ask. बोलिए.
No, sir.